The goal of this video is to give you an idea what you can do in 3D modeling software. And it's not only about creating 3D models, but it's also about creating 3D models the right way, so you can easily adjust them, you can easily modify them. We are going to talk about how you can make some movements in your 3D models, how you can animate it, how you can render 3D models so you get kind of more realistic pictures of the models what you are creating. In this video, I would like to inspire you that it's like super useful if you learn how to create 3D models. And in this video, I would like to show you some features or some possibilities and ways how this 3D model software works to give you an idea of how you can create your own 3D models and possibly what you can do with these 3D models. I'm not an expert in creating 3D models, so I found one. I contacted Kevin. He is very popular on YouTube. He has created a number of free tutorials about creating different 3D models. He has also his own company with courses teaching about how to create 3D models. And I had a call with Kevin, which I recorded, and that's what you will see in this video. In this video, we are going to talk mostly about software which is called Fusion 360, and I use it because they have this free personal license. In case you are interested about specific topic, I created chapters for this video, so you can just jump directly to learn more about, I don't know, animations or rendering, 3D scanning, joints and movement simulations. Yeah, see the chapters in the video. We are going to start a little bit more generic, so you understand a little bit around these CAD softwares, how they work. And this call is going to start with Kevin explaining a little bit about his project, what we can see here. So here is my call with Kevin. So what do we have here?
Yeah, so this is a jewelry box, really oriented towards woodworking, but I think this is a good example of a variety of things that Fusion can do. And so for starters, if you look at the hinge here, I've set it up to actually be working as well as contact sets, so this wood board won't collide. So really it's about as real as it'll get in terms of, a CAD program. The other thing that I think really makes this interesting and showcases what Fusion's capable of is that I've set up these user parameters. So I've opened this dialog here, and hopefully you guys can see this on the screen share, because I know the dialog's getting cut off. But if not, basically have a dialog here with all these different expressions.
I can see it.
Okay, cool. So if I want to change the thickness or the width of the box or something, so if I change this to 10 inches, you'll see that the box actually updates. And so this is what makes Fusion so powerful, being a parametric modeler. So you can go through and edit any of your features in your timeline down here, or drive the model with your design intent and these user parameters.
So when you say parametric, what does it actually mean when CAD software is parametric?
Yeah, so I would say, like, in its simplest terms, parametric is really about just being able to update one dimension or one aspect of the design and expecting everything else in your design to be reactive, right? So if I update the width, I want all the other boards touching it to move and everything to be correct. And really, our intent is for something to not break.
So you don't have to redraw it.
Exactly. And really, it's all about saving time and not having to start from scratch. And really, it's just setting yourself up for success and being able to reuse models. So let's say that we made this jewelry box, at 10 inches or, 100 millimeters, and then we want to make a second one, but we want to have it at a different size. The worst scenario would be that we have to go and draw the whole thing from scratch just to have a different size. Well, we could just copy this Fusion file, edit 2 or 3 dimensions, and within 5 minutes, we've already got our second model.
Okay. So this is what makes Fusion different from other softwares, or also other softwares, they have this kind of features, like are they parametric or?
Yeah, so I think it's important to note that there are other parametric, modeling programs out there, Inventor, SolidWorks, handful of others. But on the flip side, there's a lot of programs out there for 3D modeling or CAD in general that aren't parametric. So things that come
What
to
about the
mind.
free software? Do you know if they are parametric or?
Um, there's probably FreeCAD is about the only one I can think of. And then obviously Fusion offers a free personal use license for hobbyists. And so just to clarify, the free license does have some limited features in terms of majority of things hobbyists would use, especially in the design workspace. It's pretty much fully featured. So most of the features that a hobbyist would use, you wouldn't run into the limitations. Now, if you start to use more of the commercial side of it, there may be a few limitations that you'll run into.
Okay. So my question would be, because there are a number of different CAD softwares, why we would like to then use Fusion? Because they have also this free license and because it is parametric, or for me, I think my personal reason is I started with Fusion because I'm very careful about how I spend my time, and I like, if I'm going to learn something, let's learn something what I can use for all the future projects. So even if they are more complicated, I don't have to learn another software because I hit the limits of some other free software. So what do you think, why people may want to learn Fusion instead of the other softwares?
Yeah. Well, I think for starters, you called out a great point there that really the idea that Fusion is a professional CAD program. And I want to call emphasis to that because there has been a lot of confusion in the past because of them giving free access to hobbyists, that people thought it was built specifically for hobbyists, which is not the case at all. Obviously, Fusion has come a long way over the years. So the more time and money that's been invested into the development, it's become a bigger player in the professional market. So I think, yeah, for starters, being able to learn a program that you can actually use to, have a career in or make money with is a big aspect. I like to think, one of my personal favorites is that Fusion is supported for both Windows and Mac operating software. So I'm a big Mac user, and that's what I'm on right now. And so for some people, that alone can be a big difference because in terms of professional software on the parametric CAD side, there's very few options to actually use on Mac. And so a lot of times, you'd have to run Windows on your Mac computer.
I'm going to interrupt our call because now we moved to a little bit different topic, and we are going to talk about the concept of the 3D modeling software. Basically, we are going to talk a little bit about how you create very complex and complicated 3D models which are created from small parts. Okay, and Kevin is going to explain different ways how you can do this. Let's continue in our call.
And I think what's interesting about Fusion, without getting too into it, but anyone that does have more CAD experience maybe has been in other programs, even Parametric or other Autodesk programs like Inventor. And when it comes down to creating assemblies, some programs are uh, very restricted in terms of how you can approach the assembly. And so you either have to have a top-down assembly where everything's created within that file, or a bottom-up assembly, which
Maybe
is
maybe
kind
we
of the
should
old.
explain what assembly means.
Yeah, that's a good call out. So really an assembly is taking all of your parts and putting them together and using some sort of way to actually make sure that it's realistic. So in Fusion, we call them joints, and some other CAD programs that are parametric, they're considered constraints or mates. And so you can see here in the browser on the left-hand side, this is really what lists out like the assembly here. So I have what are technically called sub-assemblies. So when I designed this model, I created the base as a sub-assembly. So you'll see that I can hide that there. And if I toggle this open, you'll see that I have all the boards created as individual parts. And really that's for creating a parts list or BOM to be able to really nail down, all the parts that would be needed to actually make this. Now, going back to the difference between top down and bottom up assemblies, Fusion is very unique in the sense that you can create top down. So in this case, this is a top down model. Everything was built within this file and is related, and anything that I built after. So let's say I built this lid last. So I had the box done. I'm able to reference the actual edges of this box to make sure the lid is always, a quarter inch or 10 millimeters longer than the box. Now, on the flip side, if you take the bottom up approach, that means you're going to create a new design file for each individual part. And then at the end, you're going to insert them into an assembly. And so there's disadvantages to that, particularly when it comes to referencing other parts. It can be a challenge if you're not working with the other designer or engineer closely, or if you forget what you maybe dimension something. Now, Fusion has, in my mind, solved this most elegantly compared to other CAD programs. Let me see real quick if I have an example here.
So basically, bottom to top, it means you have individual files for individual components, and then you create one file where you use all these small files.
Yep, that's exactly right.
They are never like related together. So if you adjust length of one thing, the other things in the other files are not going to adjust the length.
So traditionally, yes, that's the case. You would have to kind of drive and know the dimensions and kind of keep them in sync. And that's often a challenge. Like if we were working together on a project and let's say we designed this tea kettle and you created the base and I worked on the lid and you didn't tell me you updated the mouth of the base or the opening to a certain size, my lid's not going to update unless I go back and change that. Now, this is a good example here because I did kind of a hybrid approach.
Oh, I see. Yeah, you have a link.
Yep. So this link icon represents this was built in a separate file and inserted. And so as long as this remains linked, we would have to, in theory, open that separate file to edit it. Now, where I was saying that Fusion really kind of solved this elegantly, and this is a lot of these features are newer in the last year. You'll see when I hover over this, there's this pencil icon for edit in place. So we can actually now edit this separate assembly or subassembly in the context of our main assembly here. So we're kind of put in this cool hybrid mode that allows us to actually not only reference other parts of the subassembly or other parts, but we can actually work right in here without having to go open that separate file. But I think what's also important is that you can always right click on this and break link. So let's just say maybe we realize we want this all in one assembly and we want that top down approach. And maybe we create a copy. So we're going to have it separate. We want to just explore some other options. We can break link. And if I do that, you'll see that now all of this is a top down approach and I'm no longer affecting that original file that I had inserted.
Okay. So now let's be a little bit more specific and let's talk about these cool features what maybe people even didn't know about they exist or they don't know how to maybe how these features may be useful. Maybe they've seen them but they never use them properly, or they never use them because they didn't know how to use them properly. And I would start with the timeline. So what is so cool about timeline?
So there's a couple things, and I think the biggest thing is, a lot of times when you set out to design something, you may not have all the requirements, or requirements may change throughout your project, whether that's like a dependency on another team or an outside factor, or maybe you just made a mistake. And so, at its simplest terms, you can go in and at any
So
time we can,
timeline is this bar down, yeah?
yep.
This,
So
okay.
this bar down at the bottom, yep.
And what do we
Yeah,
see
that's it.
there?
So you'll see every single feature or action that we've taken to create this tea kettle model is recorded down here in the timeline. So we can go and edit those at any time. So if I hover over these, you'll see I inserted the first thing with this file was I inserted this external subassembly for the base, the handle, and the spout that I had modeled separately. Then I created a component for the lid and yeah, it looks like the lid here, created a sketch for that, and so on. And
And what
so,
does it mean, for example, if you have a look on the sketch, when you edit the sketch, does it mean you are going to edit? I know it means that you are going to edit the thing, but
yeah,
I think we could maybe show what does it mean that you can actually edit the timeline.
yep. So let's look. One of the things about Fusion is you can drill down to a specific part or subassembly. So I can make this active, and you'll see that now we're looking at just the lid, and everything kind of gets this transparent, look to it. So we can focus on that. We can also hide these other ones to get them out of the way. So if I want to edit this, I can go down here. You can see all the different features I use to make this. And if I go look at that sketch, and there it is, you'll see that here I have all the dimensions and constraints that I use to make that. So maybe,
I'm going to interrupt our call again because I would like to be sure everyone understands what sketch means. And basically, sketch is like drawing on a paper. And then based on the sketch, you will create the 3D objects. So if I go into my Fusion 360, this what you can see here, this is a sketch. You can see I draw some lines and some circles. And then once I have this sketch, I can use the 3D features to create the 3D object from this sketch. So basically, in the next step, I created this 3D plane. So based on the lines on my sketch, I created this big 3D plane. And in the next step, watch what is going to happen. Based on the lines in my sketch, I created this edge of the box, what I'm creating here. And then in the next step, you can guess. Again, based on my sketch, based on these circles which are here, again, I created another 3D objects in my model. Okay, so basically in this sketch, you specify, you kind of specify what you are going to create in your 3D model. And yeah, I think everyone now understands what sketch means. So it's basically like drawing on a paper, and then based on this drawing, then you will be able to create your 3D model. Let's continue in our call with Kevin.
I just want to change the angle of this because I realize, it needs to be different. So I changed that to 140. All I have to do is finish the sketch, and we'll look back in the home view, and you'll see the model is automatically updated.
So what did we change here?
So I changed this angle right here. Maybe we can change something that's a little easier to see. So I had those holes. Let me cancel this. I have these vent holes for the steam to escape. Maybe we decide we need 5 instead of 3. We can go in here. We can just quickly change that. Click OK. And you'll see we have 5. It's a little bit messed up because I didn't update the spacing. So we need to adjust that. And I can't remember how I did this before, but there we go. It looks like that fixed it. So you can see in a matter of seconds, you can make really big changes to your design, and everything downstream will either be the same or it'll automatically update. So if we had changed something that impacted, a reference part. So if I go back to the main assembly here, and turn these back on. So let's just say if I were to edit in place to work on kind of this handle. So when I created this wood handle, I referenced the metal handle that's kind of sandwiched in between it. I could change the width of it, and this wood handle would automatically adapt to that size because I set it up to do that. So that's really what parametric is, at its core, is being able to update things with design intent and knowing that it's going to automatically propagate downstream to the rest of your timeline without you having to go back and kind of, rework everything.
So now
Now
we
the
are talking about, this is not about the timeline. Now we are talking about the parameters, correct?
uh yes and no. A lot of
Okay.
this is dependent on your timeline and making sure you actually set things up correctly. And so as someone who's maybe brand new to CAD in general or even Fusion, that's probably the hardest concept to fully get down because there's a lot of best practices and different approaches in there. And so as you're learning Fusion, one of the challenges you'll face is if you don't set things up correctly and say we go to update something, you may get a warning, so it'll flag it as yellow in the timeline, um, or an error, which is even worse. It'll turn red, which means that it lost reference to something before it. And so the key is really preparing before you even get into CAD. So I like to tell people coming up with your design intent and thinking, if I'm designing a tea kettle, what aspects would I actually want to change? Maybe it's the height and the width. Maybe it's, just the ergonomics of the handle. It really depends on the project, what you set out to solve. So there's not really a right answer there, but knowing what you're trying to do at the beginning will have a huge effect on, how successful or how parametric your model actually is.
So basically, on the beginning, you only specify the parameters what you maybe will need to change later, and everything else what you are designing around needs to be some kind of reference back to these original parameters which you manually specified and which you may change in future, and then everything else will need to adjust because they are referencing. Okay.
Yeah, it's definitely not the easiest concept to grasp, especially for folks who come from Blender or another mesh program where there's really no related concept. I find that that's always even more challenging because people are used to just getting in there and just pushing and pulling the model around and kind of jumping right in. That's why I like to tell people in some of my classes or tutorials, I tell people like the best thing you can do is think about it before you even start your Fusion file. So like I like to literally grab a piece of scratch paper and jot down, in this case, again, maybe I want the width and height to update, and maybe I want the knob to be, adaptable. And I'll think that through. And then when I start the model, I know, okay, these are the types of parameters I need to set up. And I need to make sure in my sketches that things are fully defined. So if I go to update anything, nothing breaks. So if you look at my sketch here, you'll see that all of them have this red lock icon, which represents that it's fully defined. So really what that means is we used a combination of, whoops, let me edit in place. And then, so you'll see that I used a combination of both sketch dimensions to apply the actual length or value, degrees in this case, and constraints, which you can see a number of different constraints up here in the toolbar. So constraints are simply a way to relate different sketch geometry to one another or to force them to stay a certain way. So for this example, this little icon represents a vertical icon. So I want to make sure that this tea kettle is always, vertical, and especially because I revolved it in this case. So I want to make sure this line is always at 90 degrees. And so that's one way of a few different ways that you could do that. So a lot of that takes time to just experiment and learn with. And sometimes the challenge with parametric modeling is there may be two or three ways to achieve the same result. And that's where I always tell people it goes back to your design intent and making sure that whatever you set out to achieve is the best way and the most efficient way. Because a lot of times it comes down to like keeping your sketches simple, using the modeling features in a way that's like useful but not, over the top, and really just making sure that like the simpler you keep each action in your timeline, typically the easier it'll be to kind of make sure that things update, accordingly.
So what can we do with these constraints? I know there are a couple of like super useful constraints. What I, for example, use is the one which the tangent one, I think, where you have circle and you need to have a line which is always touching the circle.
Yeah, I'm just creating a new sketch here. So I'll just sketch out a quick circle. And let's say that we have this line that I sketched out here separately. I want to make sure that you're saying you want this to be tangent.
Yeah.
So we can either select both the sketch objects first, or we can activate the different constraint that we want. And we can select the two. And you'll notice there that brought them closer. In this case, the line wasn't touching yet. So I'm just going to snap that in. So now you'll see that tangent icon appears. And if I move this, it's always going to remain tangent. So at its core, when we go to set out to fully define sketches, we're basically process of elimination going to try to restrict any movement from our sketch. So right now I can still change the size of the circle. I can still move the line around. And we're just going to work our way through the sketch and remove any ways that it can move around. And the goal is to always apply sketch constraints first and dimensions last. And the main reason for that is we want to be able to update our dimension, knowing that everything else will update accordingly. And if we have too many dimensions in our sketch, let's say we update one dimension, we may have to go in and manually change 10 other dimensions because the dimensions keep things at a certain size. But if we only have a couple dimensions and the rest are constraints, we can update that one dimension knowing that our constraints will kind of take care of everything else because it's restricting it to a certain, shape, size, or whatever it may be, depending on how we applied them.
Okay. So for example, in this case, we could, I don't know, specify the what end of the distance between middle and the end of the line, and we could specify the diameter of the circle.
Yep. So we could add,
yeah.
or here, let's say we want this line to be horizontal.
Okay.
Because for whatever reason, maybe we're connecting it to something else. So we can add a horizontal constraint there. So you'll see now I can no longer move that any other way, but our circle's still moving. So we have really two things we need to define here. The length of this line, because that can still be drawn out, and then the size of this circle. So maybe we want to connect this, I don't know, something else. I'll just enter an arbitrary dimension there. And then we'll dimension the diameter of this circle as well. So you'll notice just by doing that, all of our sketch geometry just turned black. So in Fusion, one of the ways you can tell if something is movable or not when you're working in sketches, blue geometry means that it's not fully defined. So there's still some degrees of freedom. Something can move, whether it be an endpoint or the whole object. When it turns black, that lets you know that that object is fully defined. So now I can no longer move this line at all, unless I were to delete or change the constraint here, or if I were to go in and actually edit this dimension and say we wanted it to be larger, or maybe we decide we want it to be much smaller, we can do that. So really this red lock icon is just a way to know for 100% certainty that this sketch is fully defined. So every single object in here. And sometimes it's helpful just because you may have like a sketch point out in space that you accidentally created. So if I look at this, it appears that everything's fully defined, right? But I look here and realize something's not. And so then I could select everything and kind of fix that. Or sometimes it'll be within your model or your actual sketch here.
And basically the constraints, they are telling that the line is going to be always horizontal and it's going to always touch the circle, and it doesn't matter how long we will make the line and doesn't matter how big the circle is going to be.
Yep, that's correct. So let's just make this really large for example's sake. So you'll see well, now the line's extremely
It's
small,
yeah,
but let's make that large too. You'll
yeah.
see that we still have the same exact shape. And so this is a very distinct, fully defining your sketches and doing this is distinct from using user parameters, which is us really creating a variable that we can reuse throughout the project. So maybe in this case, we want the circle to always remain this value. And let's just say we're going to call it width. And one kind of cool trick, instead of going up to this, whoops, wrong thing there, this parameters dialog, we can actually type within this input and create parameters on the fly. So I can say width equals 50 inches. And you'll see that it still says 50 there. That's what it was set to before. Oh, maybe it didn't work. We'll check here. Yeah, it looks like it did. So if I want to now update this one to width, I can enter that. Let's check here. So if we now go to that change parameters dialog, you'll see that we were able to create that variable without having to open this dialog. So now I can go in here and change this to 30 for example's sake, and notice how both of those automatically adapt. And again, because like we talked about, we set up the constraint, we know this line will always remain horizontal and that this circle is always going to adapt based on this value or dimension here.
So that's how you build the box.
Yeah.
I'm back. I'm interrupting our call again because we are going to move to different topic. So we learn about what did we learn about? Timelines, constraints, and parameters. We know how to create some 3D models, and now we would like to learn how we can put the parts of our 3D models together to create something bigger. And next, Kevin is going to explain a little bit more about joints, because this is the way how we can put these parts together, specify if they should be moving or not moving. You will see. So it is my call with Kevin.
So in Fusion, we assemble different parts or components with what's called joints. So joints are quite a bit different than other parametric programs that use constraints or mates. So with joints, instead of with constraints and mates in SolidWorks and other programs, you're essentially defining all the different ways the part can't move. So you're restricting the movement and your kind of process of elimination. And so the downside to that is sometimes it takes a lot of constraints or mates to kind of get something to work or be realistic. In this case, with Fusion, if I activate the joint command here, you'll see that we have 7 core motion types. So we have rigid, which is just like you were gluing or screwing something together. We have revolute, so that's something that's revolving. We have slider joints, and we have a few others here. So for the example of this hinge here, if I go and look at my timeline, and actually we can probably find the joint here. So let's see. I don't recall where I put it, but it looks like here it is. So I'll actually hide everything else just so it's easier to see. So we want this hinge to revolve to be real, right? So we can actually move this back and forth. And so what I did is I went in here and you'll see that I set up a revolute joint. So I can actually edit this joint. And if let's see, this is a little bit in a different orientation. There we go. That's probably easier to see. If I go ahead and use this manipulator, you can see that based on how I apply the joint, this revolves around there. Now, one of the difficulties with this, right, is this isn't realistic for this to run into the other body. And so one of the solutions for that in Fusion is that whenever you set up a joint, we can actually go in here and create joint limits. And so by doing this, I set up these limits, and if I hit this animate button, you'll see that once it gets close to there or is about to collide, it'll stop and it'll turn back and go the other way. So this is one way that you can kind of mimic or set up, realistic features in Fusion if you're actually trying to create that, realism, whether that be for simulation or other purposes, or if it's just for your own sake to kind of visualize things.
And the other part of the lid, you just connect to this wing, and it will move together with the wing.
Yep, that's correct. So when you think of joints, you kind of want to go one by one and consider how that part would actually be assembled in real life, right? So in this case, the lid would be screwed in here to this kind of flange of the the hinge here. And so if I look at this kind of top level joint folder, because I applied this to the parent assembly, you will see one of these in here. So it looks like this guy right here. If I edit that, I simply applied a rigid joint to force this board to always stay right there. Now, one of the cool things about Fusion is that applying joint origins in these joints is much simpler, again, than using like constraints or mates in other programs, because you're just defining one spot at a minimum to kind of define where it is. Now, a lot of times you may run into things where you need to position things very precisely in another way. And so Fusion also has joint alignments. And so we can manipulate things further based on that joint origin, whether we need to offset things or create them or different things there. So I'll just hit cancel, which will not make that change because I don't want to do that. But
Yeah. Okay, so you glued the lid on the one part of the I don't know how is it called, hinge, and
yeah,
and it will then automatically move together with the hinge.
yep. So I basically applied a rigid joint to kind of glue these or screw it to the lid. And then the other flange, I did the same to the base or the box here. And so just by doing that and then setting those joint limits, I'm able to kind of set this up to actually show this kind of realistic thing. Now, Fusion also has what's called context sets. So in this case, if we want to make sure that this lid never runs into any of these other parts, we could set those up to be able to kind of prevent that from happening. So some things like that, it really depends on the need of your model. If you're just creating a product rendering or maybe just creating a parts list, you really don't need to take the time to do that. Now, if you're trying to create a simulation or you want to show a product animation and show this actually functioning, then obviously it would, be more beneficial to take the time to actually do that.
How do you do that?
Sorry, let me close out some of these other files here. So in Fusion, in this symbol dropdown, you'll see that there is context sets here.
Oh,
And I can't remember. Yeah, I don't think I had these set up, but I think it was for a copy of the file. Um, so you can have it context set everything, and that'll try and make sure nothing. Whoops. So this may not. I will say that context sets, depending on the assembly, um, can be a little intensive in terms of the computer resources. It may or may not work while I'm on the Zoom call here, just because of how it is. I know on my end it's I keep getting the spinny wheel. But essentially, we can kind of talk through it. I'm gonna undo because I
okay,
don't want
it's fine.
you to
Okay,
lock up. But yeah, you would essentially define the two parts or components that you don't want to collide, and then that'll prevent them from happening. By default, this created an all context set, which means basically it's trying to avoid all of the parts from colliding, and that typically isn't, I guess, a best approach because that'll have to load a lot of different dependencies.
mm-hmm.
Uh, that's why it was kind of slowing down Fusion.
Okay, what else we have on this list? Materials and appearance.
That's a good one. So one of the cool things about Fusion is that you can create realistic product renderings. So you'll see that I added these kind of real appearances here. So up here in the modify dropdown, there's this appearance dialog. And so Fusion comes with 100 or so different realistic appearances, and they're kind of sorted by different types. So you have fabric, glass, metals, wood, and so on, painted objects, plastic, and you can simply drag and drop them. So let's say that I wanted to change. This
Change
looks
it to
like I,
mirror. What if you change it to mirror the wood part on the lid?
oh yeah, that's interesting. Let's see what that does. So
Oh,
mirror won't look like a true mirror unless we hop in the render environment.
okay.
Okay. So it's a little bit funky here, but that's a good transition. So you'll see that Fusion, we've talked about some of these, but we haven't really talked about how they're kind of set up here. So up here on the left, Fusion has all these different workspaces, which divides kind of core workflows per se. So most of the design stuff you'll be doing in the design workspace. Fusion also offers generative design. At its simplest, that's really you set up a few different um, I don't want to say parameters to get confused with the parameters of like what we did in the design model, but you're essentially creating some different limitations, and then it'll go off and the cloud computing will generate a ton, upwards of hundreds or thousands of different design ideas for you. And then as the designer, you can kind of fine tune the settings and nail those down. Now, a lot of that is more on the commercial side, and that does require some extra cloud credits. But it's a cool way, and a lot of it's more advanced manufacturing, using metal 3D printers or different things that are not really as consumer friendly at this point. Um, we have the render workspace, which we'll take a look at in a second. The animation workspace lets you set up product animations. Now, the only thing I'll call out there is the animation workspace is really just to visually show quick, exploded views of your assembly or maybe how things are assembled. It's not trying to be like a fully featured animation software. So if you do need something to be like really, highly vetted animation, you can still export your model as a certain file and then go work in a separate, animation software.
So I have a question. So if you have like gearbox, for example, and you would like to make it moving, would you use simulation or animation or?
So specific for gears, it's actually best done in the design workspace, and you can do a motion study. So as long as you set your joints up and you set motion links and potentially context sets, depending on how things are set up, you would do a motion study. In terms of the animation workspace, you're very limited to rotations and kind of dependencies. So creating something to rotate and something rotating after that, you would have to really fake it, and it would just take too much time, to be
What's
honest.
different between the? Oh, so what is different about the motion study?
So let me show, I'm just going to open this other file that I believe has an animation set up because I think this will kind of set more of the expectations of
Okay.
what animations do. So yeah, I have a couple here. So this is just a parametric standing desk that's uh, kind of the topic of one of my courses, and I have kind of a course on how to build this, and then I have this course on how to like animate this. And so the idea here for context is really maybe you design this CNC flat pack, furniture, and you want to show either a customer or a teammate how it's kind of assembled. And so if I hit play, we'll see that things are just going to kind of churn on, and then it's going to show kind of how things are assembled here. So by putting the different slots in. Oh, it looks like this was not the finished one. But the other option is you just want a simple exploded view. So maybe you have all your parts and you just want to show them explode so someone can see all the parts that go into it. So if I hit play on this one, you'll see that all the parts will just kind of come away one by one. And you can also have them come apart all at the same time. There's some different settings there. But really, this is the core of what the animation workspace is intended to do. It's really about communicating something that maybe is hard to understand if you just looked at a static image, but it's not trying to be like a true fully featured, animation software where you're doing like really cool, high tech stuff. So if I go back just real quick, you can also see there's simulation workspace. So that's where you can do static stress, fluid, all kinds of other, I think there's like 12 or 14 different simulation types. And that's really more about the physical properties of your material. So in Fusion, there's a very clear distinction between appearances, which are simply visual. So, for example, this wood appearance, the CAD program or software in this case does not know this board is wood
Mm-hmm.
unless I apply a physical material to that. Whoops, clicked the wrong thing there. So if I look at the drop down here, you'll see that physical material and appearance are two distinct features here. And if I look at the physical material, we do have a lot of the similar kind of materials per se. So typically these would match up one for one. If you're working with a plastic, you would apply a plastic, thing here. Now the difference is you'll see that plastics in the physical material drilled down to very specific types, ABS, acrylic, so on. In the appearance realm, it may be more about color, right? And sheen. So you may be finding a plastic that is opaque and you want a certain color, or you'll see like maybe you want it transparent. So those are kind of two different distinctions. Now, back to the simulation topic, you have to set up your physical materials to or to the correct type before you actually run simulations if you want realistic simulation results, right? If I wanted this to be, for some reason, maybe we want to stress test like this box or something, or
Your
the hinge.
table, you could test your table how much weight it's
Yeah.
going to.
Yeah, that's a good example. We would want to set up if these legs were going to be made out of aluminum
Plastic.
or plastic. Yeah, maybe it's an IKEA table. We want to make sure we define that before we actually run that simulation. If we just have that visual appearance, it's not going to, change anything. So by default in Fusion, all components have a steel physical material. So they're just default to steel. So that's just something you have to remember.
So what you can
Now,
simulate, how you would, for example, simulate the weight putting on the table.
so if I went to enter the simulation workspace, you'll see that it starts off by asking you to create a new study here. So in this case, we want to simulate the weight. We would start with a static stress, right? We want to put the pressure on that table. So you can see all the different types here. You can do thermal simulations. One of the newer ones that's kind of cool is injection molding, actually looking at how that part would be molded. Shape optimization is somewhat similar to generative design. We could take a part and say, we want to make it this way. We want to reduce all the material that's not necessary. And Fusion will give you a few different options and you can kind of fine tune it. And then you can see there's some other types of simulation here.
What is event simulation?
Sorry, which one?
Event.
Oh, event.
Yeah.
This one is like mimicking if something were to happen. So you can see in this icon, it might be a little small. They have like a bullet running into glass. So you could kind of mimic like try and think of an example related to this table. Um, Probably something even like let's say maybe you drop something on the
Mm-hmm.
tabletop, like would it shatter type of thing.
Is there also
Um,
like a flow simulation, airflow, or
yep, that one
which one it
falls
is?
that one falls into let's see. So there's the electronics cooling. That one does some flow stuff depending on how it's set up. I want to say that one is included in thermal, maybe. I'd have to double check. So I mainly just use stress
Okay.
simulations for
So
my,
how do you specify it on the table? I'm just curious because I have no idea how you.
yeah. So you would create a new study, and then once you get in here, you would have to actually go and define all the different constraints and loads. So you would set up any constraints. In this case, we would want to set up this table's not going to move. So we
Mm-hmm.
would put constraints on the table legs or like the top of the table to the legs, depending on how we're running this. And then we would create a structural load, right? We would say there's a load going to be pushing down on the table. And we could define, is it pushing in the direct center? Is it pushing across the table? Lots of different variables. And there's a ton of other features in here that you can kind of do. So
Oh,
there's,
okay.
yeah.
Is this
So,
part of the free license? The
so I believe on the free personal use license, you can access the simulation workspace, but running a simulation, because majority of them, if not all of them, will run in the cloud.
Okay, you
They
need to have some
require
credit.
cloud credits. Yeah.
Okay.
So I would have to double check. Simulation may not be included, so we'll have to look at that and double check. But the other thing that's cool in Fusion is you also have two more workspaces. So manufacture. This is about setting up your CAM or computer aided manufacturing. So for your CNC mills or routers or CNC lathes and so on, and as well as additive, you can actually set up 3D printed or slicing, your model within Fusion. I think a lot of people don't realize
I
this
I
because
have
it's
never
a
used
little
this
bit newer.
for 3D
And
printing.
a lot of people compare it to Kira or Prusa
Yeah,
Slicer and so
I
on.
use Cura.
Now,
Yeah.
the one thing that I'll call out there that's different is you you shouldn't compare them one for one because there's some unique advantages to doing it in your CAD program. For one, you don't have to export your model as a mesh file. So you're keeping it parametric. So let's say you export your print and within Fusion and you print it and you realize, okay, now that you tested the parts, you need to update the size, right? We can go back, update the size in our design workspace, like we were looking at earlier with the tea kettle, and our additive setup will automatically sync or reload once we select it to
So you
refresh.
don't have to set it up again. You just
Yep,
can basically start printing.
yep. So if you look at the drop down, well, uh, you'll see that the last workspace here is drawing, so you can create 2D manufacturing drawings. So we won't look into that at a deeper level, but really this is like creating your 2D drawing that you're going to hand off to the manufacturing company or maybe another engineer that, checks things or something. And so this is one of the few things you'll see there's a flyout here because you can create your manufacturing drawing from a design file or from an animation. Really, the animation advantage is if you created that exploded view, you can create that 2D drawing exploded view without having to manually kind of manipulate or tweak your design file. So for the most part, I'd say most people are creating a 2D drawing from the design file there.
So these are
Um,
the standard drawings, so with dimensions. Yeah, can you
yep.
click there? Or so
Yeah.
people know what does it mean?
Yep. So I'm just going to skip all the settings here to
Okay.
create just for sake of time. But once this generates a 2D drawing, you'll see that we'll have our flat drawing sheet and then we can place our base view. And once we place that, we can go ahead and create our projected views and really create our 2D orthographic drawings as well as an isometric view for the sake of kind of showing how this would look.
Can you create drawing
Now,
individual components?
yep. So one of the cool things in this case, right, we're really my intention for this product is really just the actual flat pack furniture here. We're not making the laptop or the table, so we can go ahead and hide those, and this will
Oh,
automatically update. And so you can see just how quickly we can kind of create this. Now, these orthographic views, like most drawings, are going to be tied together, so that way they're referenceable. Now they're a little bit small right now, so we can always edit that by double clicking, and we can change this. Maybe we'll make it. Let's see. We can keep kind of checking the size here, and you can change the visibility of lines. So if we want hidden lines to show up, we can do that. There's a couple other style settings here, um, but really the core of this is dimensioning, right? We want to be able to say what's the actual shape and size of this so someone can make this. So we can go in and add dimensions here. Pretty similar to sketch dimensions. You just select two objects and then kind of place your dimension. And you can go and do that throughout your different orthographic views. Um, and you cannot dimension any isometric views,
Mm-hmm.
at least at this time. And really, that's more of a best practice anyway, in terms of manufacturing drawings, because typically this isometric view, things can be skewed a little and it can be hard to understand,
Yeah, I have never actually seen really dimensions on these
yeah,
3D views.
you're not supposed to. And I like to call that out because I think some folks, especially on the hobby side, don't recognize that or maybe haven't learned that yet. And then they think that it's just not working.
Mm-hmm.
And it kind of calls that out for you when you try to hover over it. Um, but yeah, the
Cool.
other cool thing here is you can create different drawing sheets. So you
Mm-hmm.
could really create detailed instructions or really,
So you
you
can
know,
create sheet for every individual piece, for example.
yep. The only thing I will note is that one of the limitations on the free version, the personal use hobby version, is that you can only have one drawing sheet.
Mm-hmm.
Now, there's a few ways you can kind of deal with that. For starters, you can edit the drawing sheet size. So we could go and in our sheet settings, we could actually change the size to something to be larger.
Mm-hmm.
And so now we have a lot more room to work with. Or you could copy your file and kind of create different drawing sheets for each file. So a little bit of a pain point, but that's one of the restrictions on the free version.
Mm-hmm. Okay. And there are still few things what we would like to talk about.
Yep. So I'm going to close out of this guy and I'll close this one too.
Oh,
So
I remember now. We wanted to do the rendering,
yeah, we wanted to look at
the
how this
mirror.
looks as a mirror because we set that up and the mirror in the design workspace, it just looks white or gray here. So it's not, uh, doesn't, doesn't look that useful. I'm trying to find why or which one of these has the origin on. So this is not in the way. There we go. Oh, it's in here. There we go. So if we want to create a realistic photo or product rendering, we can bounce over to the render workspace. Now, immediately as we enter, you'll see the render workspace probably has the fewest amount of features in Fusion. So again, just to set kind of realistic expectations, you can already see that we have this looks more realistic just from the get-go. The render workspace is really about creating a visual render or photo of your product, whether it be for communicating with a stakeholder or marketing purposes or whatever. But again, it's not intended to replace something like maybe uh, Keyshot or I'm drawing a blank on the other popular one in the industry, but there's always going to be some standalone software that can really take it to another level. But I will say, like, I don't want to or kind of undermine what Fusion's capable of because a lot of it comes down to setting up the lighting properly, setting up your composition, and making sure that your 3D model itself is designed in a way to be best suited for a render. And so in the render workspace, we can set up all those appearances. In this case, I already set them up in the design workspace. We already applied that mirror appearance, so there's no need to. So really, it goes down to setting up our scene settings. So let's just say that we want to create maybe a product rendering here, and we want it to look like it was like in a typical like photo booth or something. So we have a white background. So I'm just going to change the background color to white. You can see we can control whether or not we have shadows. We can control the camera perspective. So a lot of different things we can tweak. But really, the core thing here is if we switch to the environment library, we can change how the lights are applied. So right now it's sharp highlights. So you'll see we have that really sharp shadow and kind of this highlight here. And we want a photo booth. So I'm going to drag that over and you'll see how much that changed, that
Mm-hmm.
kind of lighting. And a lot of times it takes a little bit of trial and error to just kind of test out some of these different environments and to see. So you can see there, because we applied that mirror, you can see the reflection of this plaza. This looks like a cobblestone or brick kind of street or something there that's actually showing and as we change it, you can see.
Cool.
So now we can see the mirror actually working. And it looks like, yeah, the mirrors on both sides because that 3D body was all the way through. So maybe that's actually what we want here. Now, because this does, represent like realism, we could actually place a 3D object in the background over here, and we would see that in the mirror if we wanted to. So I'm going to switch this back. Let's see, maybe the photo booth option. Now, it still is not in its full realism here in terms of what this will look like. So there's this feature here called in-canvas render. So what this is going to do is actually start the ray tracing, but it's not going to actually save your render. But if I click this, this will use your local computer. So depending on your computer specs, this may take up quite a bit of resources. But you'll actually see now the mirror works. So look, we're getting a
Mm-hmm.
little bit of the front end of the box here showing in that the bottom of the mirror there. And we can continue to manipulate and change things. And each time we move or manipulate something, it's going to start to reprocess. So you'll see that it's going to start out a little bit fuzzy. And then as that time elapses and it gets more to the excellent, it'll look more representative of what the actual final render will be. So this is a great way to kind of test your render before you actually submit the final renders. And a lot of times it just takes a little bit of fine tuning and trial and error. So in this case, maybe I don't like how like these inner support bars are blending with, the other boards. So I could go in and actually adjust the appearance. Maybe we want to apply a totally different wood appearance, or we can actually edit the appearances and make things, completely different. One thing, particular to wood, in real life, you're pretty much never going to see the same wood grain pattern. So we would want to make sure that we don't have any duplicates here, unless we were actually trying to, represent like laminate or fake wood. Um, but yeah, so if we stop the render, the final thing then really, and there are a few other settings here. You can add decals, and you can kind of texture map is how you actually control like the wood grain and stuff on that board. But if we go into render, the cool thing about Fusion is it allows both cloud rendering and local rendering. So local rendering is free for everyone. Doesn't matter what license you're on, including the personal free license, hobby license. You can generate local renders, and it'll use your personal computer's, processing power to actually create the rendering. And you can define, the resolution and file format and a few things here.
Is this going to
Now,
be better than what we have seen? Uh,
yeah, so it'll go fully. So it'll look similar to what we saw in the in-canvas render, but depending on the settings we define and the ratio, it'll typically be a better resolution and a little bit more crisp. Um, but it depends because sometimes if you let the in-canvas render run all the way to the end, you're almost seeing
mhm.
a one-for-one of what you're going to expect. So that's really why in-canvas is so powerful, is you're previewing the render before wasting time sending render after render, only to be disappointed because maybe your lighting needs, tweaks or you found something else you need to set up. Now, the cool thing about Fusion, for folks on the other licenses is that you can actually submit cloud renders. So if I'm working on a bunch of projects today and I don't want to take up my computer's resources for these local renders because it will take quite a bit of resources, I can submit a cloud render, and you'll notice that it takes cloud credits. So
Mhm.
those you purchase cloud credits in bundles, and I won't speak on the price because it really depends. A lot of times they run sales or deals on it and different things. One thing I'll call out is for folks on the education license, so students and teachers and so on. They actually get unlimited cloud credits, but they're restricted to running a certain amount, like per hour and per kind of semester. I'm going to change the aspect ratio. I'm going to lock that first just to make it larger. And so you'll see that the number of credits required is really dependent on the settings, especially the aspect ratio, how
Mhm.
large. So now it's 4 credits. But if I submit this, this is going to submit it to the cloud. And down here at the bottom, we have the render gallery. So once that's starts running, it'll show up here in the render gallery, and we'll be able to actually check that render once it's complete. If we select that, it won't show anything yet because the render's still going. Um, And the remaining time in the
Few
queue,
seconds.
yeah, it can be a bit misleading. I don't know if you caught that. It said like an hour
Yeah,
left.
yeah, I've seen it.
Sometimes at the start, it's a little bit misleading, but this typically will take, less than a minute. Part of that depends on how many other people submitted a cloud rendering, at the same time, and again, your settings, your resolution, and so on. Now, one of the cool things, once this is done, we can kind of talk about them now. It's pretty close to being done.
Nice.
We can adjust our composition and submit a re-render, and it'll use the same settings. One of my favorite things that's overlooked is we can create a turntable. So that'll create almost like a 3D file. It'll basically submit a 2D render in like 8 different positions. And so you can actually export that as like an HTML file, and if you open it, it'll load and you can actually revolve the model around in a photorealistic way. And then you can also obviously save or download the file as a PNG or JPEG or whatever file type you prefer, or delete the render if maybe you didn't like it and you need to submit it. You can also share the file with Fusion Team, which is the cloud-based storage, or a direct link to it. So it looks like it's just about done. I'm going to close this because I want to show what happens when it's done rendering is it'll actually show up here as a little thumbnail. And that's how you know that it's done rendering. And let's
Oh,
see. There we
okay.
go.
Yeah.
So, and it'll show how long it took, your resolution, a few other things there. So if we look at this, you'll see that's kind of the final render. So you can see, I mean,
It's
we
nice.
Yeah, we obviously only spent what, a minute or two setting up or kind of fine tuning the settings. So obviously, if you were doing this in real life, you could really make this even better by, adding some more shadows or doing some other lighting effects and kind of tweaking the materials. You can see in the download. So yeah, we have some pretty standard options here to download. I want to show you this
Okay.
turntable. So there's 6 frames or 36 frames. 6 frames is fine for example's sake. You'll see that it does require a lot more cloud credits.
Mm-hmm.
I do believe you can do this locally. I'm not 100% sure, but this shouldn't take too long to process because some of it's already done here. But we'll see. Let's see what it says. Only taking a few seconds. Actually,
Oh,
it looks
it's
like
finished. Yeah.
it just finished. Whoops. I don't know what's going on. Let's reopen that because it looked like it loaded. There we go. So you can see in this case, it'll just play the different frames. But if we were to drag this, we can actually drag it around, and it works a little bit better when you download it as like HTML viewer, or I guess you can do it as a video, which will show these different frames. And then obviously, if we had submitted the 36 frames view, we could really. So if you've ever seen like on a e-commerce website where they have like the 3D scans of something and you can rotate it and kind of inspect the product before you buy it, this is actually one way that you can kind of imitate that. Now it's a little bit different because some of those, I don't want to mislead people, like some of those are generated with actual 3D scans. And so it's the real product. But in some scenarios, it's a great way with a 36 frames where as you revolve it, it feels like you're physically kind of looking at the product from, any desired angle.
It's very
So kind
nice.
of,
Uh, you reminded me about the 3D scanning. It's like I don't know if you still have time.
yeah, I could go to 11:30 and then that's
Okay,
probably,
okay, okay. So let's talk a little bit about 3D scanning. I'm curious about this one.
yeah. So I'm going to close this guy. I have this 3D scan. So this 3D scan was done on the RevoPop 3D scanner.
Can
Um,
you search for it? I don't know what is it. It's
uh,
special device or
yep. Let me see if I have it behind me. So hopefully we can see this without it getting too blurred
yeah,
out. But
yeah.
this is a handheld 3D scanner. It's called the RevoPoint Pop Scanner. And then I believe they actually have a couple versions now. But this is, I think it runs at like about 500 US dollars. So really affordable for a 3D scanner compared to traditionally, a lot of 3D scanners. It's one of those things where if you have a need, it's very affordable. Now, obviously, if you're just playing around, it's by no means cheap. Like if you just want it for fun and you don't really have a
But how
use
do you
case.
use it? You have to
Oh,
hold it and go around the thing,
yep.
or
So this one works two ways. You can hold it and revolve around your object. And really, in simplest terms, this is taking um, well, there's a few different technologies for 3D scanners. One is it takes a bunch of images and kind of stitches them together. This one is more based on collecting data based on how the infrared light bounces off surfaces and then stitching all that together. So when I 3D scan this bus, this is actually an example object that comes with the 3D scanner. You can also purchase a little table that revolves 360 degrees. That way you can keep the 3D scanner stationary and let it scan the object as it revolves around. So obviously that only works well for smaller objects so you can put on the table. If I wanted to scan a larger object, I would have to hold this in my hand and kind of
so how big
revolve
is
around.
this one, or how small objects you can scan with this?
I mean, really, there's no limitation on how small. I would say there's probably more of a limitation on how large. And that's really dependent on the 3D scanner you're using and like the software and how much it can stitch together and still be able to compute.
But you get software with the scanner, no?
Yeah. Yep. So the RevoPoint comes with their own kind of proprietary software that you use. Now, talking about 3D scanners again, you can also, the newer iPhones and iPads have LiDAR scanning. And so that's also another consideration. I like to recommend those for folks that maybe don't have a true or consistent need for 3D scanning
Because
and
you will
mainly
have also phone
right, because then you also have, the
for
other
same price.
right. Now, the technologies
Oh,
are
maybe
all
no, maybe they are
uh,
more expensive, I guess.
well, yeah, in this case, yeah, an iPhone's more than the RevoPoint scanner. But if you're, depending on your needs, it can be another viable solution. And
But you also need
the
software
LiDAR,
then, no, for the phone.
yeah, there's a number of free and paid apps that work for them. I would say that's actually their limitation right now. The software hasn't caught up to the hardware in that case, at least from the experimenting that I've done. And so the cool thing though, like I have one of the newer iPad Pros, so you can actually 3D scan like your house or like larger stuff, and it's capable of doing that. I don't have if I had it handy, I would show, but I don't have that imported in my Fusion, or I don't even think it's on my computer. But I think it is cool because your iPad, for example, has that computing power, the newer ones, to actually do that and do stitch it and everything. Whereas with this Revo Point, you have to keep in mind you still need a computer or phone because you have to have it, the phone or computer does the processing
Hmm.
with the software.
And that's everything for today's video. I would like to say thank you very much to Kevin for finding time and helping me to create this video. If you would like to learn more about Fusion 360 or how to create 3D models in this software, have a look at Kevin's YouTube channel. I I have watched a number of Kevin's videos when I was creating my 3D models. Or also you can have a look at Kevin's courses. By the way, I would like to say this video is not sponsored with Autodesk or something. I just use Fusion because I like the software, and that's the reason why I decided to create this video about the software. I would like to know what you think about the Fusion 360. What do you think about this 3D modeling or creating 3D models? I would like to know if you learned something new from this video. So leave feedbacks. If you like this video, don't forget press like button. If you would like to see my future videos, don't forget to subscribe. And yeah, that's everything for today. So I would like to thank you very much for watching and See you next time. Bye. Don't forget to subscribe.